Hello students, I am Dr. Sumit Majumdar. I am a pass out of IIT-JEE. I am from the 2003 batch, and since then I am with askIITians. Today we will be learning about rotational motion. We see rotational motion all around us. Let's say we used to play a top, we used to drop it on the floor and it used to spin on its own axis. That's a kind of rotational motion. Earth rotates around sun. That's a kind of rotational motion. So let's understand about the rotational motion and its various parts. So I have broken it up into a couple of topics, subparts I should say, and we'll learn about the different ways, the different components, different things we need to understand first before we know the complete about rotational motion. So let's get going.
So what basically does rotational motion stand for? What exactly do we understand in this? So before we go on to the rotational motion, we need to understand about a few basic points. The first thing that we need to understand is what exactly is a rigid body. The rigid bodies you can see all around you, the objects which have the masses fixed at a particular point. That is what is meant by a rigid body. So whenever you have a rigid body, in that case every object or every point is going to be defined with a particular position, and therefore they are going to be having a center of mass. So they have mass at points other than at the center of mass. Obviously at the center of mass as well there will be some masses as well. Going further, you can say that each point in an object, so let's say if I talk about this as an object, can be measured from an origin at the center of mass. So if you place the origin at the center of mass, you can measure its position. So Ri represents the position vector of any mass with respect to the center of mass, provided you have kept the center of mass at the origin. Further, if the positions are fixed, if all these positions are fixed as compared with respect to the center of mass, we will say that it is a rigid body, right? Now, when it is a rigid body, we can go further and try to understand about what kind of motions a rigid body can actually undergo. So broadly speaking, we will say that a rigid body, since it is a rigid body and there cannot be any changes in within the structure of the body itself, so we will not be taking into account the vibrational kind of motion where the molecules vibrate with respect to themselves. So effectively we can say that two types of motion, namely the translation and rotation motion, actually exists. So when we talk about the translation motion, so the translation motion of a body includes the motion of its center of mass, where its center of mass actually moves. So when the center of mass actually moves, that is what is meant by a translation motion. When we talk about a rotational motion, so in the case of a rotational motion, we will say that body can also move while the center of mass is fixed. So with respect to the center of mass, you can have a moving top or a disc rotating about its center of mass with the center of mass fixed. That is what is meant by rotational motion. So once you know that we have a translation or a rotational motion, here we'll be focusing on the rotation part, right? So in this case, we'll now try to understand that what all are the forces that are acting on us. So if an object is moving in a circular path, then there are two accelerations that are going to be acting on that object. One is going to be a radially directed acceleration, which is going to result into the centripetal force or centripetal acceleration. The centripetal acceleration is going to be defined as v squared by r. It is, as the name itself suggests, is going to be directed towards the center of motion. There is going to be a tangential acceleration as well. So tangential acceleration is basically the normal linear acceleration, which is nothing but the change in velocity with time. So that can be written as r times alpha, whereas this is your angular acceleration or the radial acceleration, which acts towards the center. So if you talk about this, in uniform circular motion, there is a constant radial acceleration which is always going to be directed towards the center, that is given by this. Mind you, constant radial acceleration means the magnitude is constant, not the direction. Further, if the angular velocity changes, there is acceleration tangent to the velocity as well, tangent to the circle as well as there is a radial motion, right? So this gives us the basic understanding about what all are the basic things that are needed for a radial acceleration or for angular acceleration to actually take place, and that basically enhances the concept of radial or rotational motion. Yeah, so I'll see you next with the concept of the cross product.
So What did we learn in this? We learned about what basically are the forces that act when the body is moving in a rotational path. What is the different type of acceleration that is produced? There are going to be two types of forces that will be acting on it. So we'll learn more about it in our next thing. But before, to understand about next thing about the torque, what is the rotational analog of the force? For that, we need to understand the basic concept in mathematics, that is the cross product. So what basically does cross product stand for? So let's learn about cross product in our next session. So stay tuned.